So we have these three capacitors. They are connected in this configuration. C2 and C3 are parallelly connected, and to this parallel connection C1 is serially connected. The capacitance of every capacitor is given as C1 as 0.3 microfarad, C2 is 1 microfarad, and C3 is 0.25 microfarad. And in this configuration, the terminals A and B are kept at the potential difference of 10 volts. So the question is, what is the equivalent capacitance of this configuration? As the first one. And next, what are the charges on each plate of these capacitors, Q1, Q2, and Q3? And then we will find the total energy stored on these three capacitors. So what we do is, first let's try to find the equivalent capacitance. This is the easiest one because C2 and C3 are parallelly connected. Let's name this connection the equivalence of this two capacitor connection to be C23. Okay, so since they are parallelly connected, the equivalent capacitance is just the sum of these two capacitors, which is 1 microfarad plus 0.25, making 1.25 microfarad. Okay, so the configuration turns out to be this. We have these terminals A and B, which are kept at 10 volts, and this is C1 and this is C23, and this is 0.3 microfarad, and this is 1.5 microfarad. So next is, of course, these two capacitances are serially connected. The equivalent capacitance of the circuit can be found from this equation, 1 over C1 plus 1 over C23, and from this you can easily find the equivalent capacitance to be 0.242 microfarad. So this is the first part of the question, 0.242. I'm just leaving the calculation to you. Just will put these values, 0.3 over here and 1.25 over here, to find C equivalent. Well, that means you have these AB terminals, it is connected to only one equivalent capacitance, which is this one. Okay, but at this point you should remember that if you have two capacitors which are serially connected to each other, the charge on every capacitor must be the same. If this is you call Q1, and if this is the charge on 2, 3, we must have this is the a property of serial connection. All serially connected capacitors on their plates, they have the same charge. So Q1 and Q23 is going to be the same. And since this is the same, by just using the capacitance of the equivalent capacitor, this one, and using the fact that the capacitor is under 10 volts of potential difference, and we can find Q1 or Q23 to be just 10 volts, or V, divided by C equivalent, right? Sorry, just the Q is equal to C times V. Just made a mistake over here. This is going to be just C equivalent times V, and in turn, since we have found C equivalent to be 0.242 microfarad multiplied by 10 volts, giving us the charge to be 2.42 microcoulomb. So we've just found what the Q1 is, right? Using the fact that these capacitors are serially connected, whatever the charge on equivalent capacitor, it's going to be the same, because all serial connected capacitors will have the same charge on the plates. And since we have just found what the QC equivalent is, and since we know the 10 volts of a potential difference, we can easily find Q1 or Q23. Well, remember what the Q23 is. Q23 was the charge on this parallel connection, but the charge on Q2, C2 is Q2, the charge on C3 is Q3, so Q23 is nothing but the sum of charge on capacitance C2 and the capacitance C3. Okay? Well, what next is, in order to find what Q2 and Q3 are, we must know what the potential difference between the capacitance C2, let's call this V2, and V3, the potential difference between the terminals of the capacitor C3. If we know this potential differences, then just by using C times V equation, we will be able to find the charges separately. Q2 to be C2 multiplied by V2, and Q3 to be C3 multiplied by V3. But since these two are parallelly connected to each other, in fact, for parallel connections, this V2 and V3 are just the same, because for all parallel connected capacitors, their terminals are at the same potential difference, because this point and this point is the same, and this point and this point is the same. So V2, V3 is going to be the same. That means it is the potential difference between this C23. Let's call this V23, and V23 is just Q23 divided by C23, right? And Q23 is just 2.42, and C23 is just we already found that to be 1.25 microfarad. Okay, so this is going to be as a voltage is just 1.93 volts. Okay, and of course V23 is just equal to V2 and V3. We know that V2 and V3 are equal to V23. So to find Q2 is just multiply C2 by V23, which is C2 is 1 microfarad, and multiply this by 1.93 volts, you get 1.93 microcoulomb of charge on the capacitance C2, and Q3 is going to be just C3 multiplied by V23, and that is the C3, which is 0.25 microfarad multiplied by the same voltage, 1.93 volts. You find Q3 to be 0.483 microcoulomb. So that accomplishes the second part of the question. This is Q1, this is Q2 and Q3, and just to check, we had this relation at the beginning. Q1 is going to be just sum of Q2 and Q3, if you add these, you will find that the addition will give you this value of Q1. Okay. Well, the last part of the question is just to find the total energy stored in the capacitor, and the total energy stored in the capacitor can be found by using the expression for the total energy, electrostatic energy for capacitors. Let's use this space to do this calculation. So we have this relation for energy stored in a capacitor is 1/2 CV square. Okay, you can either use this one or 1/2 Q square divided by C, or 1/2 Q times V. All three equations are equivalent to each other, but let's use this first one because we know what the equivalent capacitance is. All right, in this circuit is equivalent capacitance is just this equivalent capacitance was, let me write this from our earlier findings, it was just equal to 0.242 microfarad, and we know what the V is. It is 10 volts, so it is 1/2 0.242 microfarad multiplied by 10 volts V squared, 10 volts squared. You will find the total energy stored to be, if you do this in your calculator, 12.1 microjoules. Okay, so but this total energy, in fact, sum of electrostatic energies for each capacitors C1, C2, C3, you can check this result by doing this U1 plus U2 plus U3, and U1 is going to be 1/2 C1 V1 squared, and 1/2 C2 V23 squared plus 1/2 C3 V23 squared. These are already found, and you can just check if you put these numerical values over here. This sum will also give you the same. Just for verification, you can check this. Okay.